with that radius you have to make this circle. That becomes your inscribed circle. Now what we do, we take this radius and we draw the required circle. This is our circumcircle. So just in 2 steps, okay. So this is how you draw in circle. So these are the 2 tangents that we wanted, PM and PN. Okay, so these are the 2 tangents that we wanted from an external point. So our tangent at the point of contact to a given circle of a given radius is done. Welcome all of you. So today we are going to only clarify all doubts about construction. Okay, I can hear too much of doubts. Too many people are asking construction, how to make an incircle, how to make a circumcircle. Okay, you can also clarify your doubts on incircle, circumcircle, orthocenter, okay, incenter, circumcenter and centroid. I have a separate video only for that, which will help you in your MCQs. But today I am going to take up constructions, all the different types of constructions that can be asked. Another thing, I'll be uploading a separate video on previous year's questions where I'll be talking about how they mix up constructions and loci. Okay, in the exam they don't have a direct construction question. Always it has been mixed with it. The concept of loci and construction together has been asked. So let's start with construction today. Every doubt will be cleared. Please see the video from the beginning to the end, because throughout I'll be telling some new thing in this chapter. Okay, so firstly, the very first type of construction, we know our concept, we know the concept of that if there is a circle and for the circle the tangent at any point P always makes 90 degree with the radius. Okay, this you already know from your circles and tangents chapter. So let me quickly show how to draw one tangent to a circle when the circle of a given radius is given. Also, I want to tell you all, I am going to upload a separate video on construction of triangles. Okay, that is because when construction, everywhere you have to construct a triangle. Now there are some students who are not very clear about construction of triangles. Now they are having doubt in that how to construct that triangle. So a separate video on different types of constructions of triangles will be uploaded very soon. Okay, so let's see this, how to construct the tangent to a circle. Now the tangent, supposing they have given 4 centimeter radius to a circle of radius 4 centimeter. So you draw a circle of radius 4 centimeter, and then what you have to do is take a radius anywhere. Okay, they have told mark a tangent at any point P. So you just draw a radius with your scale and extend it little bit like this. Okay, now this is your point of contact, which is going to become your point of contact for your tangent. Here you have to turn your notebook. Okay, so in construction there is a lot of turning the notebook. So turn your notebook, and as I turn your notebook, now over here from this side you'll have to make a semicircle. Once you make a semicircle, now you will construct a 90 degree. Okay, so you stay hooked to the channel, because one video only on construction of 90, 60, 45, 120 will also be uploaded. Okay, so here now you construct a 90 degrees. So this is construction of a 90 degree. Now don't try to take a compass and do it. When you don't try to take a protractor and do it. With protractor also you can do, but when you do it with compass, then only you get your full marks. With protractor they will deduct marks. So this is your point of contact P, and from this point of contact, now hold your scale. This is the point of contact. These 2 points we are going to join. One thing you must know before we start geometry: if we want to draw one straight line, a correct straight line, the wanted straight line, we have to have 2 points. Without 2 points, if we have just 1 point, we can never draw the straight line. If I just draw one, I have only 1 point here, then maybe person A is drawing it like this, person B is drawing it like this, and person C is drawing it like this. Then which is the correct line? So in order to get a correct line, we need 2 points and then a minimum of 2 points, and then only we can get the correct point. So here the 2 points are these two. You can see one is this point of contact, one is this intersection of arcs. Now take a scale and join them. This is your tangent. You have to do some turning of the notebook. That's all. Okay. So here is your 90. Why did we draw it like this? Because the radius always makes 90 degree with the tangent. That's all. Okay. So our tangent at the point of contact to a given circle of a given radius is done. Okay. Now we'll now do a tangent, two tangents to a circle from an outside point, means this point is at a distance of, let's say, 10 centimeter from the center of the circle. How do we make two tangents to the circle without mistake from an external point? Okay, so let's see. So tangents from an external point. Tangents from an external point, how do you do? Now if you have a circle, supposing they have given a circle of radius 4 centimeter, to this circle you will have to make two tangents from an external point which is at a distance of, let's say it is at a distance of some 7 centimeter. That is, the point P is at a distance of 7 centimeter from the center O. Okay, so what we do is we hold our scale and draw the point P, fix the point P at a distance. We measure 7 centimeter and we draw it. Okay, then what next is we will be making a circle which will pass through this and this, means this OP becomes the diameter of our new circle. If we want to make this as the diameter, then we have to have the center of the circle. And how do we get the center of the circle? We'll have to make the perpendicular bisector. Okay, once we make the perpendicular bisector, this is 90 degree as well as it cuts the line into two equal parts. Now here also for OP, taking the compass, fixing it here, pulling it up to more than half of OP. Your compass, when you fix it here, should come up till here at least. Okay, if it is below this half, it will not give you a correct figure. So you have to pull the pencil end at least till here from here. Okay, so and when you from here you make an arc like this and make an arc like this. Use the same radius, don't change the radius, fix it here, cut this arc, and so fix the compass here, arc here and arc here. With the same radius, fix it here. So your radius has to be more than half of OP. So here goes my, okay, this is a rough diagram, so I can see lots of problems. So this is my perpendicular bisector of the line OP. Why did I draw it? Because I wanted this point. Okay, I just wanted this point which is going to be the center of my new circle. Now fix it here, pull up your pencil till here. Okay, fix the compass here, pull up your pencil till here, because this becomes the radius, and draw a circle which goes like this. Okay, so you have drawn a circle which passes through this point P will be in the circumference, this point O will also be in the circumference. What is important now is these 2 points. These 2 points become very, very important. Why? Because we are going to take, as I told, we need 2 points to draw a straight line. Now these 2 points become very important. This point here, let me name it as M and join to P. Name it as N and join to P. You have got your tangents from an external point. Now why? What is the concept behind it? The concept behind it is very simple. I have a circle here, and you will note with this dotted line, you see this OMP, angle OMP is equal to 90 degree because it is angle in a semicircle. If I can get a 90 degree with this radius, that means PM is tangent at the point M. Similarly, angle ONP is also equal to 90 degree. So if I can get a line which is 90 degree to the radius ON, then PN is the tangent. So it is based on this concept. This is why you see for the bigger circle, This angle ONP is a angle in a semicircle. Okay, this is coming from your circles theorem. So these are the two tangents that we wanted, PM and PN. Okay, so these are the two tangents that we wanted from an external point. So anytime if they give you the length, if they give you the distance of the external point from the center of the given circle, you should be able to draw the tangents. Now let's see the next thing, which is inscribing a circle in a triangle. Inscribing a circle in a triangle. How to inscribe a circle in a triangle? Now here is the triangle. Now this triangle construction, as I have told that I'll make a separate video for the construction of the triangle. Now I am not going into the construction of this triangle. I'll just name it A, B, C. Now inscribing a circle in a triangle, okay, in a triangle. Okay, so that is a very important question for your exam. Okay, how to inscribe? What we'll first do is we will bisect two of these angles. Angular bisection also I'll teach in one of the videos. Okay, so where I'll teach perpendicular bisector, angular bisector, bisection of an angle, all these in a separate video. Now here when I make angular bisector, okay, these two lines will definitely intersect at a point. Even the third angular bisector also intersects at a point, but we don't draw it. Okay, we don't draw it. Why? Because it is not required. Why? Because angular bisectors are concurrent. That means all the three angular bisectors will always meet, for every triangle will meet at the incenter I. Okay, so here this is the incenter. With just two of them I got the, because they are concurrent, only two is enough. So I got the point. Okay, I got the incenter. Now from this incenter, what I have to do is I will have to make a circle which will be inside the circle like this, inside. Okay, it should not go out. So these sides of the triangle should be tangents to the circle. How to do that? Now here what we have to do is once we got this point, from this point we'll have to drop a perpendicular. Okay, you can't take here and we have to drop a perpendicular, that is extend the radius of the compass and make an arc like this from this point. And these are the 2 points from where I make 2 more arcs. Okay, and then join. Okay, it should, okay, as I join it should pass through the intersection of the arcs. Now this line is perpendicular to the line BC. Let me call it IP. Okay, so IP is perpendicular to BC. Why I needed a perpendicular? Let me clarify that first. See, now when I have a triangle like this and you say I've already got the incenter, people don't give much importance to this, but you don't even get your marks without this. If now you say, okay, this is my radius. Okay, this is my radius and I can draw the circle. I can adjust the compass and draw. But then what happens if you say this is the radius? Some person is holding the radius like this, somebody is holding it like this, somebody is holding it like this. Nobody holds it correct at the point of contact. Only then you will have, because in an incircle, these distances are equal. These three distances are equal. And what is, when we say distance, it means the perpendicular distance. Okay, so that is why we need this perpendicular line. Okay, if we hold it here and we measure it here, we are going to get a wrong circle. Taking let me name it as M, IM as radius. Now we draw a circle which passes through, okay, it becomes, these sides all become tangents now. So this is my Incircle. The circle should not cross this line or this line. It should, all this line AB, AC and BC should all be tangents to the given circle. They should all be tangents to the given circle. Okay, so this is how you draw incircle. I'll give a repeat for this, quickly a recap. That is, all you have to do is, after you make the circle, two angular bisectors, just two, perpendicular to one of the sides, any one side you have to draw perpendicular, measure radius, these are the steps, and once you measure the radius, draw incircle. Okay, so in an incircle, I repeat, these distances are going to be same. So you can draw a perpendicular this side or even this side, that is immaterial. Every side is going to give you correct answer. Okay, so that is it. Let's move on to circumscribing a circle around a triangle. That is the next important question where you are very, very confused. So let's see. Now the next one is circumscribing a circle around a triangle here. Now what we have to do for this, again that triangle, I am not going into drawing that triangle, construct the triangle with the whatever data they have given. Okay, and once you have constructed the triangle, now you will have to, actually circumscribing is easier. Now you have to make perpendicular bisectors. Why perpendicular bisectors? Because circumscribing is, you have a triangle and the circle goes like this. Okay, so we need the circumcenter. The circumcenter is at equal distances from all the vertices. So if we get the circumcenter, we can get the radius for the circle. So how to get the circumcenter? Circumcenter is the point of intersection of the perpendicular bisectors. Again, the circumcenters are concurrent. They are all concurrent. Therefore, only with two we can manage our diagram. So here we draw the perpendicular bisector. Now just before this also I taught you perpendicular bisector. Okay, so you have to join the two arcs. You get one perpendicular bisector, extend it a little bit, and one more perpendicular bisector with the arcs. Okay, and they come and meet at this point. Now this point, the point of intersection, that is the circumcenter. The concept says that perpendicular bisectors are equidistant from the vertices of the triangle, of the given triangle. Okay, now as I said, they are concurrent, therefore we don't need the third one, because even if we had drawn the third one correctly, it would have met at C. So minimum we have to draw two. Okay, we don't need to draw the third one. Now remember one thing, circumscribing is actually easier than inscribing. You have to do one step less. Okay, now here take this radius, CA. CA is the radius. You can even measure CB as the radius. You can even measure CC as the radius, because circumcenter is equidistant from A, B, C, from the vertices. Circumcenter equidistant from the vertices, incenter equidistant from the sides. Now what we do? We take this radius and we draw the required circle. This is our circumcircle. So just in two steps, perpendicular bisectors, measure radius, okay, measure radius, and now draw circle. Circumcircle is outside, incircle is inside. So this is the fourth important thing that can be asked from this chapter. But remember, they are not going to give you a question so direct as this. They are going to mix it up with other things. Okay, now we will be drawing a hexagon. First, drawing a hexagon. Now they will say hexagon of, draw a hexagon of side. Hexagon of side, how much? Let's say 7 centimeter. Okay, hexagon of side 7 centimeter. How to draw? All you have to draw, first draw a line 7 centimeter in length with your scale. At this point, make a 120 degree. Now why 120 degree? Because internal angles, these for a hexagon, internal angles are equal to 120 degree for a hexagon. So we'll have to make we'll make a 120 degree over here. Again, with your compass, pull up the compass and measure in your scale. Don't try to do it with the holding the scale. Take the compass, measure 7 centimeters and cut an arc where it comes to 7, because they'll be looking for this line. They'll be looking for this line. This is your new vertex. Here again 120 degree. Here goes your new line. Measure 7. This is your new. From here measure 7, cut an arc, make a semicircle and 120 degree, measure 7, cut an arc, okay, make a semicircle 120 degrees. See, 1 2 3 4 5 is already done. Cut an arc here 120 degree and here it comes. So this is your, this is actually your regular hexagon. I went little, this is a rough figure, so it doesn't look like a regular hexagon, but then it's going to come perfect if all these angles you can take correctly as 120 degree. You'll see that last one you don't even have to draw, you don't even have to draw 120. If you just join these 2 points, it's going to come to a 120. Now the question says hexagon of side 7 is drawn. Now they are saying circumscribe a circle around it. How do you circumscribe a circle around a hexagon? Now all you have to do is draw the perpendicular bisectors again. Perpendicular bisectors of any of the 2 sides, any 2 sides, and you'll see that it comes and meets here. Okay, this is the point P. Now what you have to do is, since you are circumscribing, take any vertex, A, B, C, D, E and F. These are the vertices. Please name and give it to them. Okay, there's marks for all this naming and everything. So here, fix your compass here, pull it up till A. That means measure the radius OA. That becomes your radius for the circumcircle. And then draw a circle which passes through all of these, and you got your circumcircle. So what are the steps? Draw line of the given length, make 120 degrees, repeat, you can say 1 2 3 4 5 times, or even 4 times is enough. Okay, repeat 5 times, make hexagon. That much for a hexagon. And then draw perpendicular bisectors, for any 2 sides, Once you have drawn it, you have drawn the perpendicular bisectors of any 2 sides. Okay, point of intersection, take point of intersection with any vertex. Okay, take radius, the point of intersection of the perpendicular bisectors with any one vertex gives you the radius. Take radius, draw circle, that is circumscribe circle. Okay, so these are the steps, this much for hexagon making, this much for circumscribing. Okay, now we'll have a question. If we have circumscribing, we will also have a question for inscribing, right? So how to inscribe now for a hexagon. Now inscribing is, here I'm not drawing the hexagon anymore, but you'll have to construct, they will tell you to construct this also. The difference between hexagon, circumscribing and inscribing is, the previous one we did perpendicular bisector, here we are going to make angular bisector. Okay, angular bisector, here it goes and they are going to meet at a point. Actually all angular bisectors will meet at this point. For an inscribed circle, the circle has to pass all these lines. Okay, A, B, C, D, E and F. All these lines of the hexagon actually make tangents. So what we do now, again that dropping the perpendicular from here, drop a perpendicular onto this side like this, and now measure this. This is the point P, OP, measure OP, that is your radius. With that radius you have to make this circle, that becomes your inscribed circle. So first construct hexagon. Make angular bisectors. Angular bisectors for two of them. Two of the angles. Okay. Drop perpendicular from the point of intersection. Drop perpendicular from point of intersection of what? Angular bisectors. Okay. Point of intersection. Drop perpendicular from point of intersection. Now draw in circle. Okay, how will you draw the incircle? You will take this one as the radius. Please don't take the vertex as the radius. Your circle is going to become a. Please don't take the vertex as the radius. Your circle will become a circumcircle in that case. Okay, so that was it from this video. So these are the basics of construction chapter. In my next video, I shall be taking up previous year's questions where locus and circumcircle will be mixed, and in those questions how to solve those questions. Also look out for my video for how to make different angles. Okay, different angles in construction, how do you make them, like 60, 45, 30, 90, how to bisect an angle, how to make perpendicular bisectors, how to drop a perpendicular. Okay, and another separate video will be coming for construction of angles, construction of triangles. Okay, so that is it for today in this video. If you have liked the video, do not forget to comment. Your exams are coming close by, so please subscribe, because videos are going to be uploaded till your final ICSE final exams. Thanks all of you. Bye then.